IB Physics, May 2024, Time Zone 1, SL Paper 2, Question 2. A student throws a ball towards a wall. The ball is released from a point 1.8 meters above the ground and 8 meters from the wall. The initial velocity of the ball makes an angle of 48 degrees with the horizontal. A resistance is negligible. The diagram shows the initial path of the ball. P is a point on the path. For part A, we're asked to draw on the diagram an arrow that shows first the velocity of the ball at P. And we're told to label this arrow V. Well, the velocity is going to be tangential to this curved path. So your arrow should look something like this, and it's labeled V. Next, we want to label the acceleration of the ball at P. Well, gravity is going to be the only force acting on this ball, and gravity is accelerating the ball down. So A is complete. Moving on to B here, the ball takes 1.3 seconds to reach the wall. The initial speed of the ball is 9.2 meters per second. Determine the height above the ground at which the ball hits the wall. Alright, so we'll call this height H. And H is going to consist of this 1.8 meters because the ball is going to come back down and hit the wall here. And this distance between these two lines here is going to be S sub V, the vertical displacement, because the release point was 1.8 meters above the ground. So we have to factor that in separately. That's the 1.8 right here. So we can say that the height above ground at which the ball hits the wall is 1.8 plus the vertical displacement, S sub V. And S sub V, well, we can use our kinematics part of the data booklet to see we have an equation where S is equal to U times T plus 1/2 AT squared. But we're dealing with the vertical component, so we're dealing with U sub V. So what we have here is 1.8 plus U sub V times T plus 1/2 AT squared. So what is U sub V? Well, I believe there is another part in the data booklet that will help you figure this out as a quick shortcut. But let me just explain how we reach this equation that is given to you. So we have a vector U, that's our velocity vector. And there are two components to this vector. We have U sub V, the vertical component, and U sub H, the horizontal component. And then we have theta here. So using trigonometry, we can say that sine of theta, which is opposite over hypotenuse, is equal to, well, opposite is U sub V, right? I could just move this arrow over. So we have U sub V over hypotenuse, which is U. If I solve for U sub V, I'm going to get U sub V is equal to U times sine of theta. So going back to this equation here, I can plug that in. But let me also plug in my value of U, which is 9.2, and my theta, which is 48 degrees. And then, of course, we can't forget this T multiplied by T. And T is 1.3. Then we have plus 1/2 times A. A is the gravitational acceleration, so it's negative 9.81. And then T squared, so 1.3 squared. And then we can plug all of this into a calculator, and it will give us an answer of approximately 2.4 meters. Now this is my final answer because I'm looking at the significant figures and what's given to me.